Thank you very much. And just to explain that we are kind of two keynote speakers, that is that I will ask Eric not to advise me when there's 5 minutes left, but 10 minutes left. And then Leoncio will step in and tell some of the story from his point of view. Yeah, now it's completely different. There's no medical information here. It is geology and it's technicalities within how to extract gold. Yeah, these figures you know, and the advantages is that the countries hosting all these small-scale miners, they earn a lot of money, and it provides food on the table for millions and millions of people, and it reduces urbanization. All these things are quite positive. Of course, there are negative things: land degradation, health problems, and the global pollution. Small-scale mining is a very, very, very old thing. The first indications is from the Greek mythology about 3,000, 4,000 years ago, in those days where the Greek gods reigned the world. And there was a guy called Jason, and he was not in favor of the gods, and the gods were very angry at him, and in order to please them, he was asked to perform a number of different things. And one of them was that he was supposed to find the golden fleece. And you can see this is on the right side there. The golden fleece, it has been for many years, it was thought that it was a picture of something else. But actually, it was really a golden fleece, because in the very old days, the herdsmen, when they butchered sheep, then they dried the fleece, and then especially at the springtime when the water came rushing down the mountains, then they put the fleece out in the river, and it stayed there for a month or two, and then they came back, and then they either burned it or shook it, and got all the gold out of it. And it was actually quite a lot of gold. And I can tell you, some years ago I worked in the steep mountains of Kyrgyzstan, and actually I found a fleece lying in the river. So it is in action. And on Mindanao I saw not a fleece lying in the river, but a carpet. So they put the carpet out in daytime and let it stay for a couple of days, and then they took it out, dried it. Now I will give you a brief line-up of the different types of small-scale mining which I've come across during my period. This is from Mozambique. You can see especially the guy on the left side, it is very, very primitive. He's just digging out some soil and try to get gold out of it. And the other one, it's more advanced. This is a gold vein which is about 5 to 6 meters down, and you can actually, which one is it, this one? No, it doesn't work. But you can see the trace of the gold vein. Now we are looking for tantalum. That is metal we use in our mobile phones, and that is in also very, very primitive in Nigeria. Then we have dimension stone, and you can see that is pretty scary. That guy there is standing, he has no protection of anything, and he chisels out big blocks. That's all on a small scale. Here is some small scale coal mining in Mongolia, And you can see they are concerned about safety. On the picture right, you can see there's an incline down underground, but they have realized that it starts to collapse, so they have put this thin piece of wood in to pretend it to collapse. And they actually also, as the coal miners did in the old days in UK, they sometimes bring a bird down there, and when it drops dead, they know it's time to get up. Then in Laos, they have several types of small-scale mining. This is a salt mine where they pump some water down into a salt layer, and then they pump it up again, and then they use all this wood to heat it and evaporate the water. They also have tin in Laos, and then they have a very special thing which I think is quite unique to Laos. They small-scale mining of iron and explosives, because this is close to the Ho Chi Minh track, where the Americans dropped more bombs than through the whole World War II. And you can see many, these are the shells, and the children find the shells, and then they drag them down, and sometimes they find also the unexploded things, where they then open it and sell the explosion, and the metal is sold as metal scrap. That was a brief through different types. Then I'll give a small brief description of the different steps in from mining, processing, and until we have the commodity. Here we have different types of mining. In the right we have normal placer gold mining high up in the Kyrgyz mountains, and I presume you know all what the placer mining is, but if you don't, it is digging up gravel which has been washed down the mountains, and there's small amounts of gold and gold nuggets in it, and then they let it run through these chutes, or where the heavy stuff gets stuck in the bottom. Actually, these guys, I worked for for World Bank, and they were so impressed that World Bank were interested in their problems, so they had found a gold nugget about this size here, which they gave me. And I said, I can't receive it, but my guide, the man with the funny hat, he said, well, it is really something for them to give it to you, and in appreciation that World Bank does something for them. Then we have underground mining. You can see this is from Tanzania, and you can see how solid they support the entrance, the tunnel, the shaft down there. But it's only supported 2.5 meters, because there's no mining inspectors coming there who check further down. And then there's some mining in Zambia for emerald, and you can see that is all, according to all normal rules, very, very dangerous, because that stuff collapses. Here is, I guess, the most unique mining I ever came across. That is gold mining in Suriname. That guy there, you wouldn't believe it, but he has some mercury in a piece of cloth, and then he squeezes it, and so some small drops of mercury fall out, and he goes like this and spreads the mercury on the ground. And Ilse, who has worked there, she has also seen it, so it's not just me who has dreamt this up. So this guy, he spreads it out, and then he collects it again and get the gold out of the place. And I saw his processing site, and below that I could see mercury all over the place. So now we have mainly on hard rock mining, because that's the main issue I work with. And you dig it up from a pit, you dig it up from a shaft or from some tunnels, and then you have to crush the rocks to about, say, walnut or plum size. And in the old days in Tanzania, where I started, he was sitting there, and they sit there the whole day. And in Mozambique, where I was a few months ago, they are on the same level. Then in Zimbabwe, they have these hammer mills, which is remnants from the British days. They are quite efficient, but very, very expensive to run, as opposed to, I think there was someone who showed a jaw crusher, but not all people can afford that. Now we have the gold ore in this size, and it has to go down to powder size. And again, we have the ancient method. You have a tree chunk, and you make a hole in it, and then you stand with the axle of a car, and you stand like this. It works, but it takes time. There are other ways to mill and grind the stuff. On the left side, it is in the Philippines. They have these drums, which take 2 or 3 sacks, maybe 30 to 50 kilograms, and they add water in it. Whereas in Tanzania, and also, for instance, in Mozambique, they have what they call dry milling. And it's obvious that it has many disadvantages. It's terribly noisy, and you can see all the dust. So we go to other types. There's no limit to the imagination of people how to get this yellow metal out. The upper right thing with the big wheel is what is called a Chinese wheel, and the 2 or 3 wheels, depending, they turn, and then they roll in this channel, and you put your crushed rock into there, and then it runs and runs and runs and runs, and it takes an awful long time. Then in Peru, they have an even more time-consuming thing. You can see this little tub type of thing, which is chiseled out of the rock, and next to it there's a piece of rock standing like this. So they put their ore, their crushed ore, in that, and then they put the stone into there, and then they stand like this, and it rocks back and forth. It takes a whole day. And in Nicaragua, they have another way to do it. It's called a rastra, and it is 3 or 4 huge stones about this size, and they are linked to a machine, so they're gradually churning round and round and round and round, and it takes forever and is unfortunately highly inefficient. When you have milled it, in some cases, you put it in a chute You take the milled material up there in this bowl and then let it run down there, and there's a piece of cloth, and all the heavy minerals are captured in the cloth, and then when it has run for some time, you take the cloth and clean it into a tub of water, and like the ones here, and then you start washing it. This is Leoncio teaching a guy in Sudan. So now we have come down to the almost final step. So that's where we have to go to the Mercury story. And nearly all small-scale gold miners, they use mercury. They use it in different steps, and in some steps, I would say, if they just went on with that, the future of our planet would be much better. But unfortunately, they develop to more efficient ways. Now, you have had enough of that. So, so this is gold extraction using mercury. The simplest model. So you crush your rock, you mill it, and you can do sluicing, you know, along this decline, and then you start panning, and then you add your mercury to the pan. And you can see the guy there has a lot of milled gold ore, and he adds some mercury and makes it thoroughly. And then he can easily, by adding some water, he can get the mercury concentrated, and then through one or two steps, which you don't need to hear about, then you burn the amalgam. You see up there, he has the mercury and the amalgam. For you, those of you who are not completely knowledgeable in that, amalgam is a gold mercury mixture. Mercury has a peculiar capacity against silver, against gold, and a few other, zinc, I think, a few other metals that they can, it's not physically correct to say, but it kind of dissolves gold or silver. And it's, for silver it's used here, and when it's gold, silver, or mercury, silver, then it's an amalgam. So he has the amalgam there, then he puts it in this little iron cup, and this young guy, he is very keen to get the gold out, so he blows vividly, and of course when he blows he has to suck air in, and he gets the mercury vapor straight in. And the final result is down below here. And as you have heard in the previous one by Raoul, that this is then sold to a gold dealer who burns it again to get the remaining gold, the remaining mercury out. So, what are the advantages? The advantage is it doesn't require very much equipment. So, for very poor people out in the bush who say, well, we have no other means of income, or in the winter time when it's dry, we have no work to do, so they do some gold digging, and they can recover some mercury. It has disadvantages, as we have talked about, and also mercury is quite expensive to buy. But I would say, again, that if they could stay with the mercury in method 1, we didn't really need to be here because of them. But they have decided well, why should I sit with my hands and mix the mercury? Why don't I use a machine for it? And this is where it gets really bad, and that's what causes our main problem on planet Earth. So they do the crushing and milling, and the milling in drums. And then they add, so the crushing and milling, and they put the mercury in the mill, because they say, well, the mill is much more efficient in mixing it, the mercury with tiny gold particles, which then can be amalgamated and captured, which is correct. No problem with that. Yeah, there's a problem, but the logic is fine. Then they do the sluicing, and they make the concentration, and then they burn the amalgam. So, why is it so bad? The big problem is what we call mercury flour. And I don't know how many of you are the age where it was allowed to play with mercury in school. I'm of that category. We got everyone in the class a small droplet of fluid of mercury, and then we pressed it and it spread out. And then you took the small droplets and pushed them together again, so they all coalesced. And that is the capacity of mercury. They can coalesce. But if you have beaten mercury bang, bang, bang for a certain length of time in a mill, then it's beaten to tiny, tiny spheres. You can see how small they are in this tablespoon, and all the small shiny dots are mercury flour. And you can imagine how difficult it is just to try to pick them out, to say it's impossible. But the problem is they have lost the capacity to coalesce. So even if you could take them, you couldn't push them together. And that means you can't capture them. So this is the real culprit. And mercury flour has another very unfortunate capacity. Because they are so small, they float on water. These two pictures are of, you can see mercury flour on both of them. The left side one, it is a very thin film with tiny drops of mercury flour, and they just go out with the water. And the other side, it's a thick layer of mercury flour, and there's no way the miners can capture that. And what does that mean? Well, it means that they lose a lot of mercury, but they also lose a lot of gold, because all the gold which was captured in the process just goes out. This is a huge mountain, so to say, of tailing somewhere in the Philippines, and I took a few grab samples there, and I analyzed them, and you could see it contained 16 and 14 grams of gold per ton. A normal gold ore used by the small-scale miners would maybe contain 5 grams of gold, and this here is just lost, and it contains high amounts of mercury. So that's where we have the problem. So many people realize that, and about 20 to 30 years ago, someone said, well, why don't we distill it? And they invented the retort, which is shown here. I also tried it. The miners did not like it very much, unfortunately. Some miners in Tanzania said, well, we can't see what happens to the gold. And that particular donor said, well, we'll make retorts of Pyrex glass, $500 for each, and they break just like this. So it was not a very good idea. So retort in principle is good, but it doesn't work. They don't like it. So we come to the Philippines. Many years ago, of different ways, I ended up in the Philippines, and I was told that about 30 years ago, there was a bright, small-scale miner. The story may be a bit different from who tells it, but a small-scale miner saw that maybe in a gold mine laboratory that they tested the gold ore, and they used a white powder to melt the rock. And he said, well, why don't I use it? And then he used it, and that's the area where Leoncio is living, and it spread to that area, and for the last 30 years, a fairly large number of people went mercury free. But what was very strange was it didn't spread to the rest of the Philippines. It was kind of an enclave. So Leoncio and I, together with Dialogos, we decided, well, if they can't do it themselves, we'll give them a helping hand. So the method there is just like the other one, and you make a concentrate and add the stuffed borax. Now, many of you will say, ooh, borax, that's bad stuff. Well, I'll remind you that all the laundry, the clothes you have, they've been washed in detergents with lots of borax, and there's been a survey in China by Danish and Chinese medical doctors in a borax mine where the Chinese miners are really heavily exposed to borax, and they have had no problems with fertility. And the effect of borax is that it reduces the melting point of everything. Melting point of gold is 1063 degrees Celsius, and no small-scale miner can achieve that temperature out in his little village. But if he uses borax, he can do it. So here you see Leoncio on the upper left one, and it means that the miners who became very lazy because they used the mercury, which could capture the gold, so they kind of forgot how to make a good gold concentrate. But Leoncio says he can teach any small-scale miner within 24 hours to make such a good concentrate. Then you take the concentrate, put it in a small piece of plastic. If you have some environmentalists around, you take a banana leaf, because some of them immediately say, oh, no, don't use plastic. And then you put it in a clay bowl and have some pieces of charcoal, and you heat it. And what happens is that all the minerals, because there are still some minerals, it's not pure gold, you can't make a pure gold concentrate. There'll be some iron-rich minerals and some silicates also. But the effect of borax is that all these minerals, they melt and they go into what we call a borax glass. But gold cannot fit in there. Gold is an element which is not very welcome in most environments in nature. So it's kind of sticks to itself. So all the minerals, they go into the glass, and the gold melts and sinks to the bottom, and we get this It has, if there's silver in the gold, there will be silver in that also, but it's clean and nothing else. So, what is the advantage? We have much higher gold recovery. Why is that? Because we don't produce mercury flour. So we can recover 50% more gold than if you use mercury, which is, without working considerably harder, there's no health hazards, you get a higher price of gold. And then we'll go to the next. What?
10 minutes left together with the answer.
Yeah, I'm almost through. Yeah, the thing is that you produce this mercury flour if you use mercury, but if you don't, you all recover all the gold. And then there's one thing which many people don't know. The advantage of borax is that you melt the minerals, I said. And some of the minerals, for instance, this one, you can see, this is a mineral called arsenopyrite, which is quite common in gold ores. And you can see all the small yellow dots, that's pure gold. And any other process than borax cannot capture that. Whereas borax will melt the arsenopyrite, and thereby the drops go down. Yeah, we make this demonstration. I tell the small-scale miners, you will earn 50% more gold. They look at me as I look at my politicians when they promise so much and never fulfill. And then we make a competition, and we take 10 sacks at random and let the miners process that, and another 10 sacks, and we process it. And the first one we had, the miners recovered 7.5 grams, and we recovered 22.4. In that area, 1,800 small-scale miners who were convinced, and they have used mercury-free ever since. And now it is your time.
Thank you, Peter, my twin brother. Well, I am Leon Sunaoy, a small-scale miner in the Philippines, and we had been advocating stop mercury as gold catcher in SGM. For several years, we had been successful doing that in our place, and then eventually Peter came. And with the help of course, the Dialogos and the other NGOs, we were able to spread to other countries. With this methodology, we had a very rare experience that happened in Kalimantan, where this methodology did not work. That is in one side, and in the other side, it worked. So there's something about it, something needs further study. And then in Peru, we also had a very successful result. The miners were inclined, and before we lived there, they were inclined to say that they are going to adapt and they will continue using it. But after a quarter of year, when we went back, nothing happened. We observed that our sample pan was left behind rotting, and we do not know what's the cause. Maybe we can find solutions in our workshop on Friday. As a small-scale miner, I totally agree that the source of perplexity in small-scale mining is we lack systematic mechanism to keep things moving. 4 years ago, I started the cooperativism, thinking that it will integrate the economic part of sustainability. So I took it to mining site as my pilot project, and in 5 years, the two cooperatives is working good. It is moving forward. So the cooperativism might not be the exact solution, but in my observation with this testing is moving on, so I think it would also be considered. With this, I think the time is already up, so thank you for listening.